In 2009, Polyglass decided to begin producing synthetic membrane in PVC and TPO in a very big way. Substantial investments were dedicated to the creation of an innovative, state-of-the-art productive unit that has permitted the expansion and completion of its range of waterproofing membranes. The production of these synthetic waterproofing membranes in PVC and TPO is fundamental in the offer of all the solutions required by users. These materials are produced with the latest characteristics using the latest techniques. Polyolefin and polyvinyl chloride PVC synthetic waterproofing membranes are used widely in civil construction, roofing and the waterproofing of large surfaces in particular. This involves highly specialized work that's widely appreciated in Italy and abroad. Polyolefin and polyvinyl chloride PVC synthetic waterproofing membranes can be made both with and without internal polyester fabric and glass fiber reinforcement, in this way ensuring a complete solution to every waterproofing requirement and application conditions anywhere on Earth. The range of Mapeplan synthetic products is also characterized by two different colors. The TPO products are indicated in green, while the PVC products are designated in blue. These two distinctive colors are repeated everywhere, and on the product data sheets as well. The Mapeplan line has also been expanded with the addition of a range of PVC products developed expressly for utilization as liners for swimming pools, artificial ponds and ornamental water tanks. The line is known as Mapepool and obviously comes with its own detailed technical documentation. Here we are in our virtual construction site. Our two expert installers will show us how to apply a complete and insulated layering of products. We'll begin by laying a double adhesive bituminous vapor barrier known as Polyvap SA. This will be topped by an insulation panel. The final layer will be a synthetic waterproofing layer in TPO fastened mechanically. The job will be completed by the necessary finishing details. Here we are applying the first layer, the double adhesive bituminous vapor barrier known as Polyvap SA. A real revolution in this type of product, Polyvap SA, is a 2 mm thick bituminous membrane with aluminium foil reinforcement inside that guarantees a complete vapor barrier. Watch how the experts make the vertical turn-ups to a height of around 12 centimeters up the wall. That is amply above the height of any reasonable accumulation of rainfall. Now they are stripping away the first half of the anti-adherent protective film from the inside of the bituminous membrane. This film is easily stripped away because it has been pre-cut into two halves, and this seals the membrane perfectly into place with no chance of slipping. Now they're stripping away the second half of the monosiliconated protective film. You can see how fast the work goes. No torching is required, and everything is done in absolute safety. Now one installer is rolling the vertical turn-up using a commonly available metal press or roller. The other installer is positioning the second layer, which will be applied with a 10 cm longitudinal overlap over the first vapor barrier. This is the size of end lap that we recommend. Now he's unrolling the roll, which is 15 meters long and 1 meter wide. Here as well, two installers can work rapidly and easily together. The monosiliconated protective film on the first roll is partially lifted up to expose the bituminous compound underneath that will seal the application. The third roll is being positioned now, always with a 10 cm overlap. The top part of the roll near the wall is pressed down to the laying surface in order to keep it from slipping and accidentally losing its linear alignment. And then the rest of the first half of the protective film is stripped away from the inside of the bituminous membrane. Now the other half of the third roll is folded over. This is possible because the other half of protective film has not yet been stripped away from its bottom. Now you see them pulling away that other half of film. 10 or 15 centimeters of bituminous membrane are exposed in order to ensure overlapping and sealing. It's very important not to make overlaps on the monosiliconated protective film. And now the membrane is folded over into its definitive position with the greatest of ease. Here we can see one installer passing the metal pressing roller over the vertical turn-ups, while the other applies pressure to the longitudinal end lap. There's no need to apply pressure to the central part of the roll, because even very short exposure to sunlight is enough to completely activate the bituminous compound. The application of primer before laying any bituminous membrane, including self-adhesive types, assumes fundamental importance because primer eliminates all traces of dust and significantly improves membrane adhesion. Here we are, ready to apply insulation panels over the vapor barrier. Our two installers will first remove the monosiliconated protective film from the vapor barrier membrane's upper side, or extrados, and then position the panel. This panel is in polystyrene foam, but obviously extruded polystyrene or polyurethane panels can be applied as well. Now the monosiliconated protective film is being stripped away from the membrane's upper side. The black part that you can see is obviously self-adhesive and therefore permits the laying of insulation panels quickly and easily. No mechanical fastening or bituminous glues are required. The vapor barrier is not punctured. The panels are simply laid on top. These are normal panels without any special edging or tongue and grooving. The speed of laying is another one of the system's great advantages and is translated in a laying output that is 30 to 40% higher than in traditional techniques. As you can see, the top side of the panel is well below the bituminous membrane's vertical turn-up, which will be trimmed away so that the synthetic membrane that forms the finishing layer never comes into contact with the bituminous compound. This is an important part of the process. As you can see, the second row of insulation panels starts from the wall with the panel previously cut in half in order to avoid having the points of contact between the rows of panel on the same line. In addition to ensuring the insulation system's greater mechanical stability, in this way the points that may form thermal bridges are interrupted. See how the panels are laid staggered. When removing the monosiliconated protective film, it's very important to avoid stepping on the exposed bituminous layer in order to avoid soiling the self-adhesive face and compromising subsequent adhesion. The protective film must be removed only as little as necessary for the positioning of the panel. Watch as the installer makes sure to walk only over the protective film. As you can see, we've laid nearly 15 square meters of insulation panel in a very short time. Now our installer is trimming away the excess vapor barrier turn-up with the use of a simple tile cutter. Here the installers are taking the measurements required for the positioning of the mechanical fasteners. The distance between one fastening point and the next is usually around 30 centimeters and depends on various factors such as windiness and the design specifications in question. Now we are ready to watch mechanical fastening. As you may know, synthetic membranes are not usually fastened in the middle but rather at the overlap points. Here we'll be using metal fasteners in galvanized steel of variable size that depends on the laying surface and a shape that permits them to be fitted inside the waterproofing membrane. In this installation, the insulation panels will not be fastened mechanically because, as we've seen, a double adhesive bituminous vapor barrier was inserted below that makes mechanical fastening or the use of glues completely unnecessary. In the absence of a similar double adhesive system, such as the application of a vapor barrier covered by a sheet of polyethylene, for example, also the insulation panels must be secured by inserting one mechanical fastener per panel. In this case, we use a square mechanical fastener with larger surface area that ensures greater adhesion. Here we see how fastening is performed in a series of steps. The first installer drills the hole and the second screws in the fasteners. Mechanical fastening is essential to the system's success and usually performed by specialized installers provided with specific training. Here it's worth remembering that the Polyglass Technical Department holds dozens of courses every year for operators who want certified specialization in this technique. Now we're ready to apply the final layer. In this case, a synthetic waterproofing membrane in TPO polyolefin, a product with internal polyester fabric and glass fiber reinforcement. Like all other synthetic membranes, this product, Mapeplan TM, comes in rolls of 210 or 160 centimeter width and can be fastened mechanically. Overlaps are sealed by hot air blower, as will now be shown. The product being unrolled has a 1.5 mm thickness and vaunts smart white technology. As you can see, the surface is white for the highest light reflectivity and transmission in order to keep the underlying area as fresh as possible. The SRI, the Solar Reflective Index, is 102, an excellent value indeed. Now we see the installer making his preparations for the creation of an inside corner.